Okay, so this time we're going to do molarity problems. So, on the right here, we have what is the molarity of an aqueous solution containing 50 grams of glucose in 2 liters of solution. Now, the formula for molarity is moles, which is N, over liters. Okay, so in this case, we have 50 grams of glucose, which is bad. We don't want grams, we want moles. So, we first have to convert 50 grams into moles using dimensional analysis. Now, we have grams on top, so we have to have grams on bottom, and we're converting to moles, so we put moles on top. Now we're going to put a 1 in front of moles, because every time we have moles in a conversion factor, then we need a 1 in front of it. And then next to grams, we need the molar mass, which is C, the molar mass of C times 6 plus the molar mass of H times 12 plus the molar mass of O times 6, which turns out to be 180.156. Sorry, I don't have quite enough room there. Then we do our math. So 50 divided by 180.156 equals 0.278 moles. Okay. Now, again, looking back at the formula, we have moles on top, liters on bottom, and we have 2.0 liters, so we put 2.0 on bottom. And so we take our answer from our grams to mole problem divided by 2, and that is 0.14 with sig figs, because it's actually 0.1387 blah blah blah, but 2.0 has 2 sig figs, so it should be rounded. Our answer should be rounded to 2 sig figs. And then, of course, we can't forget our units, which is capital M, and that's it for that one. Okay. Now the next one, we have how many grams of NaOH are in 250 milliliters of a 3.0 molar NaOH. So now this time, we are looking for grams, okay, which our formula does not have in it, but it does have moles again. Okay, so first we have to find moles using molarity and volume. Now again, our formula is liters, not milliliters. So we have to convert 250 milliliters into liters, which we do by moving the decimal to the left 3 places. So our liters is actually going to be 0.250 liters, and that's going to be on the bottom. Our top number is going to be X, because we are doing we are trying to find moles, and that is going to equal 3.0 molar. So we have to solve for X. So what we do is take what we do is we take 0.250 and get it on the other side to get X by itself. So 0.250, 0.250, and so 0.250 cancels out over here. So we take 0.250 times 3, and we get 0.75 moles. Okay. Now, next, that's not our final answer, because again, it says how many grams of NaOH. So now we have to convert our moles into grams by using the molar mass of NaOH. Okay, so we do our conversion factor. Sorry, we're going to run out of room here. Let me erase some stuff. Oh, that's really small. Nope, that's not what I want either. Okay. All right, so now, on bottom we want moles, and again we want a 1 in front of moles. On top we want grams, and then we need the molar mass of NaOH next to grams. So molar mass of Na is 22.99 plus 16, which is oxygen, plus 1.008, which is hydrogen, and we get 39.998. Okay. So then we take 39.998 times 0.75, and we get our final answer of 29.9985 with sig figs. That's going to be 30 with a decimal because we need 2 sig figs. And if we put 30 without the decimal, then we will only have 1 sig fig. And that now is your final answer.